So for this warm-up, it's a review of order of operations, and we've got two different people simplifying an expression, and we want to know, is either of them correct, and explain your reasoning. And if we go through here, obviously the first thing we should do is look inside the parentheses. We see an exponent, we do it, then we do the multiplication, and then we do the subtraction. Notice what Tara did. She subtracted 9 before she multiplied. Right here is her mistake, because we know that multiplication comes before subtraction. So right here is her mistake, so she is incorrect. Here we can see Curtis multiplied before he did the subtraction, so he has it right. So Curtis did the correct work. Tara had a mistake in her order of operations. She subtracted before multiplying. So that's why she's wrong and Curtis is right. Today we're going to be talking about properties of numbers, and first thing we need to talk about is equivalent expressions. Equivalent expressions are expressions that represent the same value. They are equal. Equivalent means they are equal. And we're going to have a bunch of different properties today. The first property is the reflexive property. When you see the reflexive property, think of a mirror reflecting, and it says any quantity is equal to itself, which means A is equal to A, and examples 5 equals 5, 4 plus 7 equals 4 plus 7. Not a very exciting property, but the reflexive property, anything is equal to itself. The next property we have is the symmetric property, and it says if one quantity equals a second quantity, then the second quantity equals the first. Seems kind of confusing, but basically what it means is if A equals B, then B equals A. Should make sense to us, and we can kind of think of this as symmetry. If we say A equals B, then B equals A. If I draw a line right there, you can see it's symmetric on either side. That's where we get the name, the symmetric property. So an example would be if 8 equals 2 plus 6, then 2 plus 6 equals 8, using the symmetric property. Next we have the transitive property, and that says if one quantity equals a second quantity and a second quantity equals a third quantity, then the first quantity equals a third quantity. With words that sounds really confusing, but here's how, if we look at symbols, it becomes a lot easier. If A equals B and B equals C, then A equals C. So we can see A is the same thing as B, B is the same thing as C, which obviously means A is the same thing as C. And here's our example. If 6 plus 9 equals 3 plus 12, and we know 3 plus 12 equals 15, since 3 plus 12 is the same thing as 15, then obviously 6 plus 9, which is the same thing as 3 plus 12, would also be 15. If A equals B and B equals C, then A equals C. That's how the transitive property works. Then we have substitution property, and that just says a quantity may be substituted for its equal in any expression. And that basically just means if A equals B, then instead of writing A, we could write B. Which means that if n equals 11, then instead of writing 4 times n, I could say 4 times 11. Basically, the substitution property says, if it means the same thing, then it doesn't matter which one you have. We've got some addition properties. We've got the additive identity. Whenever you see a property as identity, it means nothing is changing. The identity is staying the same. And that says the sum of any number and 0 is just that number. So anything plus 0 is itself. So like 2 plus 0 is 2, 0 plus 2 is 2. Then we have the additive inverse. Whenever you see inverse, that means we're kind of undoing something. We're going backwards, we're inverting it. So a number and its opposite are additive inverses of each other, which basically means if I take any number and add its opposite, so for example, if I had 2 and I added the opposite of 2, which is negative 2, I will always get 0. Any number plus its opposite is 0. And we've got some examples. 3 plus negative 3 is 0. And the second one doesn't look like it would be an opposite, but remember, adding a negative is the same thing as subtracting a positive. So 4 plus negative 4 is 0, but that's also 4 minus 4 being 0 is technically an additive inverse. And we've got even more definitions. Got 3 more, and these are for multiplication. Multiplicative identity. anything times 1 is itself. That's your multiplicative identity. So any number times 1 is just itself. Remember, the additive identity said any number plus 0 was itself, any number times 1 is itself. We have the multiplicative property of 0. You guys already know this. Anything times 0 is 0. And then we have our multiplicative inverse, which says for any number, there's exactly one number that if you multiply it, you get 1, which is just the reciprocal. We've talked about that. So if I take 4/5 and I multiply it by its reciprocal, I would get 1. Any number times its reciprocal is 1. That's what this identity is saying. Any number multiplied by its reciprocal is just going to be 1. We can see that in our example. A over b times b over a is always going to be 1. So a lot of definitions, a lot of properties, but you will be able to look back at this. Hopefully you will start memorizing some of these, but just have these all in your notes so you have them to refer back to.